I'd like to give you just a little bit of background on Dr. Steve Austin. I will not read the entire Vita sheet that he's given me, as he asked me not to do that. But there are many things that can be shared with you tonight to give you some understanding as to his proficiency as a scientist and the credibility that he brings with him to share the things that he'll share with us. Let me just read a few things to you. Dr. Austin spent 10 years at major state universities receiving his training in geology, in which he holds 3 academic degrees: a Bachelor of Science from the University of Washington in 1970, a master's degree from San Jose State University in 1971, and his PhD from the Pennsylvania State University in 1979. He was a lieutenant in the United States Navy, serving 3 years as an instructor of oceanography and intelligence in San Diego. His training and experience in the geology of oil, gas, and coal have allowed him to serve in a consulting capacity with government and private individuals. Currently, Dr. Austin is Research Associate in Geology with the Institute for Creation Research and President of KEMAR Resources, Incorporated. He has written several technical papers on geology and a book technical, it is readable. So you might want to keep that in mind for the layman. Currently, he attends College Avenue Baptist Church, where he serves as a deacon and leads one of the largest singles ministries. See that Stephen not only knows what he's doing in ministry. I want you in just a moment to help welcome him, that he's chosen Earth, really billions of years old. Dr. Austin, welcome to Valley Christian Center. Let's welcome him.
Enjoy the fellowship of day 2 of your very fine seminar that you're putting on. And we are just really pleased at the interest and the enthusiasm that is expressed toward us and the subject material that we're presenting. And we want to meet your needs as best we can. And this evening, I noticed as I came in that there are virtually no books to us. And so I talked to the business department at the Institute for Creation Research, and they told me that they were put on the bus for tomorrow night's session. So if there is a book that last night, because it sold out, I'm sure that it'll be back on the table again there tomorrow night. Tomorrow night should be our main book sales night, although several of the books are still there on the table. I'll call your attention to several of those. The layman's pack is perhaps the best introduction to creation science. What is creation science? And the book Evolution, the Challenge of the Fossil Record, Dr. Dwayne Gish's book. And What is Creation Science is also there on the book table. A very excellent book, probably one of the most interesting books as far as the relevance of creation to the modern Christian is the book The Lie. And talk about a book that can be, has illustrations that can be effectively communicated. Here it is. Professor Ken Ham, his book, The Lie, Evolution. And also I wrote a book, and it's on the book table that Pastor Whitlow mentioned, my book, Catastrophes in Earth History, a source book of geologic evidence, speculation, and theory. Now, most of the book is in plain English, and if you can understand my lectures, I think you'll understand the book. Well, anyway, we'll be having a better assortment of books on the table tomorrow night, but you're free to pick up any book that's there. I understand that we ran short of book lists, and we ran short of other material, other free material. And so I was able to get, we'll bring some more of that for you tomorrow night. If you were here last night and you heard Dr. Gish talk about the fossil record and about the origin of life, you basically have what Dr. Gish will present at the debate tonight. And so don't feel bad about not having been to the debate. He shared with me at dinner that he was going to talk about 3 things at the debate. He didn't want to divulge this ahead of time so that the evolutionists might be prepared, but he's going to talk about the laws of physics and chemistry and how the universe could not have created itself by the present laws. The present laws are destroying the universe. He's going to explain that in the debate and challenge the evolutionist, Professor Donaldson, who is a physicist, to build the universe with the, from hydrogen gas with the present laws, physics and chemistry, and make even the human brain 120 billion brain cells, that type of thing, 12 billion brain cells, 120 trillion connections. And then the next thing that Dwayne mentioned he would talk about is the probability argument, the probabilities like of the simple living molecules and how they could have arisen by chance, and the probability argument. And then the third thing he was going to talk about was the fossil record. So he talked about that fairly well last night, so you have a pretty good overview of what his presentation and debate will be. No doubt there'll be a tape or something available. Maybe you can find out what the evolutionist response to that particular subject is. Well, maybe tomorrow night we'll do that as well. Maybe we'll have an eyewitness report. Maybe a couple people come back and tell us what they thought of the debate. So if you're here tonight, don't feel bad about it, because we should be able to find out more about how that debate went. Okay, let me begin by pointing out that my first lecture this evening is the lecture, Is the Earth Really Billions of Years Old? We found that most people ask this question, one of the most important first questions, so we will deal with that tonight. I was thinking about giving a lecture on the scientific accuracy of the Bible, which is also a favorite lecture of mine, but most people have a good grasp of the scriptures and how they are scientifically accurate, I understand, and so we decided we'd give this lecture instead. And this is probably more relevant to the questions that might come up with skeptics. Is the Earth really billions of years old? It's almost one of the cherished notions of our time. You can question just about anything, even evolution theory and the mechanisms that Darwin proposed for how life evolved. But one thing you do not question is the notion that the Earth is billions of years old. Some people, even Christians, feel so strongly persuaded by this evidence that they feel that they must accommodate their interpretation of Genesis chapter 1 to the evidence the billions of years age for the Earth. You might have heard of various ways of thinking about that, various theories, the gap theory, the day-age theory, progressive creation, various kinds of theories that suggest that billions of years were involved with God creating. Although a Christian might propose a literal interpretation of Genesis chapter 1 and would appear that creation occurred in a very short period of time and not very long ago, just thousands of years ago. And so this question, is the Earth billions of years old, is tremendously relevant to the Christian today. And we go into museums or we read in our textbooks and magazines various notions about geologic time. And we have the geologic time scale. It almost is a once upon a time story, millions and millions of years ago. Or as Carl Sagan says, billions and billions of years ago, and billions of stars, and billions of galaxies. The number billions just seems to make it into evolutionary arm waving. Well, the geologic time scale. The geologic time scale, and they've got numbers on the rock strata in millions and billions of years. Life is supposed to have evolved supposedly about 3.5 billion years ago. Some people suggest even older than that. And the Earth is supposed to be 4.5 billion years old. And so billions of years are involved with the evolutionary suggestion of the history of the Earth. Well, is that really true? And are there billions of years? That's the question I want to consider tonight. And I want to consider the geologic evidence as a geologist for billions of years. Well, let's begin by telling you a story. And it's a yes.
Can I just break in for a moment if I can get a mic here? Hello. Oops. Hello, here I am. If those of you that are sitting on the far wings would like to move, I think there are still some rows available, and please just get up and move to a section that will give you a little better view
of the screen.
If it's large like that, you can probably see, but if it gets small print, you might not be able to. So if you want to, please feel free to move. The ushers will assist you. Sorry to break in.
Okay. Well, let me give you an overview, and then I'll tell you the story. Here's the overview for the question, is the Earth billions of years old? Let me ask 9 other questions that relate to that one major question. And here are the questions I'd like to deal with in overview tonight. What assumptions are needed to estimate the age of the Earth? What assumptions are needed to estimate the age of the Earth? How long would it take to erode the continents down to sea level, make the continents into a plane at sea level? And how long could the continents endure? Here's another question. How long would it take for the ocean sediments to build up? The sediment in the ocean. What does that suggest about the age of the Earth? Billions of years? Does it? Okay, number 4. Does the ocean salt content suggest a billion-year age? The salt in the ocean and the way it's being added from creeks and streams and rivers. Does that suggest billions of years? Number 5, do the rocks and fossils take long ages for deposition? How about those rocks and fossils? I'll be talking more about that in the second lecture tonight on fossils, flood, and fire. And then I'll be going on discussing that more tomorrow night when I deal with Mount St. Helens and Grand Canyon, 2 of my favorite subjects. Does the property of stratification in rocks require long ages to form? And then number 7, does erosion breaks between rocks formations require long ages? Number 8 is kind of interesting. Does the erosion of canyons require long periods of time? And number 9, do the abundances of radioactive isotopes in rocks require millions or billions of years? The number 9 point is one that evolutionists often refer to most thoroughly and say that proves billions of years of Earth history. So I want to spend about the last 10 or 15 minutes of my lecture tonight dealing with that one. But I'll be going through these fairly fast. Let me tell you the story first and see if you can relate to this story. One day, there were 2 spaceships from the planet Mars that came to Earth. They came to Earth for the particular purpose of understanding something about high school students. And one of these spaceships landed at Fresno Christian High School, and the other one landed at Emmanuel High School, I guess, okay? And the purpose of the investigation was to find out the average age of a high school student. And rather than believe the reports of parents or the students themselves, the Martians decided they would engage in scientific experiments and measurements to estimate the average age of a high school student. They disbelieved, in fact, they were skeptical of what the parents had said about the ages of their sons and daughters, and they, of course, disagreed with the high school students' own claims about the age of their age. So they decided to set out about and do some measurements. The first measurement they did was the average height of a high school student. And over a 3-year period, the Martians at this one high school here in Fresno measured the average height of all the high school students that they could find. And they found out that the average height of a high school student is 65 inches high. 65 inches high. And over the 3-year period, the average growth rate of a high school student is 1 inch per year. 1 inch per year, and the average height is 65 inches. And so they did a little calculation in their mind, 65 inches high, and they grow 1 inch per year. What would the observation about the height of a high school student suggest about the age? 65 inches divided by 1 inch per year gives the notion that the average high school student, on the basis of its height, is 65 years old. Okay? Now, independently, the other spaceship went to that other high school, okay, and they measured the weights of the high school students. Okay, and they measured hundreds of high school students, and they found out the average weight of a high school student was 130 pounds. 130 pounds. And over the 3-year period that they observed the high school students, the average weight gain was 2 pounds per year. 2 pounds per year. And average weight was 130 pounds. Now, how would the age of the high school student be calculated on the basis of the weight? Well, you'd take the weight, perhaps, the average weight of a high school student, 130 pounds, and divide it by the rate of weight gain per year, and that would give you the age. Take 130 and divide it by 2, what do you get? 65 years on the basis of their weight. So the Martians got back together on their mother planet as they went back to Mars. They discussed this whole thing, and they had done a scientific test for the average height and weight of high school students and came up with the idea of 65 years as the average age of a high school student. Now, both methods seem to agree. Would that strengthen the confidence, you suppose, of the Martians as they studied and looked at humans here on Earth? I think it would. What would the Martians assume about the average height and weight of a high school student when they were born? They'd weigh 0 and be less than an inch high. Okay. Were they justified in extrapolating the height and weight gains from the 3 years of observation over the entire lifespan of the student? Boy, some colossal assumptions were involved there that might appear to be reasonable, but in their final analysis are pretty flimsy. And that shows us that some of our ideas about age of things can be tremendously mistaken, and they're related to our assumption base. They disbelieved the actual parents' and students' statements about age and went on and concluded falsely that the average high school student was 65 years old. Well, here's this diagram. It shows the data and interpretation. You know, we can look at the same data, the high school data, for example, high school student data, and come up with different interpretations. How is it that we can come look at fossils and strata and come up with young age or old age ideas? How come we can come up with quite different interpretations? How is it that I, once an evolutionist, believing in billions of years of Earth history, could change my opinion about the age of things and even start questioning the idea of billions of years? How come this thing exists? This is shown on this next chart. Notice how that works? Bias A goes through the data and determines interpretation A. And bias B goes through the data and leads to interpretation B. One day I was wearing these sunglasses, these pink sunglasses. You put them on, and for the first 10 minutes you see everything pink, but then all of a sudden everything goes back to its normal color. You know, biases are that way. They affect our interpretations of things. We need to realize that we have biases like this. If you begin with evolutionist biases, you lead through the data to evolutionist interpretations. And you would come up maybe with billions of years age for things. If you're a creationist and begin with creationist assumptions or creationist bias, you lead to creationist interpretation, even young age. So that's something to think about. Well, let's go to the candle analogy. Let's say we saw a candle burning right up front in the room here. And the question we'd want to ask is, when was the candle lit? We see the candle burning in the room at the present time. When was the candle lit? Well, one way we can get some idea about the candle is method number one is look at the candle. We can estimate the age or time of burning by doing a calculation. If we know the original height of the candle, and we can observe the present height of the candle, and we know the rate of consumption by burning, we can do this simple mathematical calculation and come up with the age or time. But notice that we have to know the original height of the candle. Was anybody here maybe when the candle was lit? Maybe nobody actually can confirm the original height of the candle, and so this method doesn't work in the final analysis. We might place some confidence in the idea of candles. We go out to the store and we see all the candles of this particular type are this high, but we have to make some colossal assumptions. Factor X gets into this calculation. The original height minus the present height divided by the rate of length consumed by burning gives the age, the apparent age of the candle, but it has all those assumptions, just like the Martian thing. Okay, a number two method is look at the smoke in the room. That's another method. Instead of looking at the candle, let's look at the smoke in the room. And the age can be estimated from the amount of smoke. We can get a cubic foot of air, measure the amount of smoke that's in the air. We can measure the rate of smoke production by the candle. If we assume that all the smoke has come from the burning of the candle, and we know how much air is in the room, we know how much smoke is in the room, just do the division, the amount of smoke in the room by the rate of smoke production, that'll give us an age. And there's a division problem there. Look at the smoke in the room method. Okay, but I noticed that the doors are open. Okay, smoke could be leaking out, or smoke could be added from outside. And we have air conditioners, and there could have been smoke originally in the room before the candle was lit. All kinds of problems get involved with that smoke in the room kind of assumption about the age of things. I'll just call your attention to that and think about the colossal nature of those assumptions. Most of the radioactive dating techniques make the method number 2. They look at the smoke in the room, if you will. And we need to realize the assumptions that are involved in that. Do you know what number 3 method is for getting an idea of the age of the candle or time of burning when it was lit? Pardon? Okay, a guess, but there's the best method I can think of. Method number 3 is ask someone who saw the candle being lit. Okay? That'd be the only way you could prove it in a court of law. You could come up with all of these calculations and logical arguments based on various presuppositions, but the only way in the final analysis you'd prove it is if you had a historic observer who could tell you the answer. And creationists say that the Bible is a valid historic document of prepared by the Creator to answer many questions, including when was the candle lit. And so God could reveal to us in propositional form the answer to that problem, how old is the earth? And evolutionists say only method number 1 and method number 2 can be used, not method number 3, because there was no historic observer that can validly claim with reliability that he knows how old the earth is or when the candle was lit. So those are the 3 methods for the candle analogy. Well, let's look at some of those methods. Let's talk about the time it would take to erode the continents down to sea level. How long would that take? I've done a simple calculation just to give you some ideas or impressions about the nature of the very severe process of erosion that's occurring on the continents today. You know, we know the massive continents above sea level by topographic mapping over a large area. We have a very good idea of the average elevation of the continent and the area of the continent. And it turns out we can convert that to a mass, the volume to a mass. It's about 383 billion tons of rock above sea level. And then you can divide that by the rate of continental erosion, the rate that continents are eroding today. We have very accurate, fairly accurate measurements of the sediment content of rivers going into the ocean. And over the period of over 100 years, we've made some very good measurements as to the amount of sediment that's in the rivers. And that's of course coming from erosion of the continents. 27.5 billion tons per year. A colossal quantity of material is being removed from the continents every year by just simple water erosion, particularly other methods as well. 27.5 billion tons per year is a good estimate of the rate of the continents are weathering or eroding. When you do the division problem, what do you come up with? 14 million years. Now think about that. That's an apparent age, or the length of time the continents could endure above sea level. But think about, what do the evolutionists say about the age of continents? They say that continents are very old, 3 billion years old. And ocean basins are very old, about 3 billion years old. It's interesting, it doesn't look like the continents have even been eroded down to sea level one time. And yet the very potent agent of erosion could cause the continents to be eroded down to sea level at the present rate of erosion in just 14 million years. So that seems to be contrary to the notion that the continents are billions of years old. Well, allied with that question about how long the continents could endure is the question, how long would it take for the sediments to build up on the floor of the ocean? And here's a calculation just indicating the time it would take to build up sediments in the ocean. We have very accurate surveying and mapping going on at the present time of the ocean sediments, and seismic studies of the ocean floor and even coring of the material on the ocean floor has given us a fairly good idea about the thickness, average thickness of ocean sediments. We can convert that to a mass. Turns out about 410 million billion tons of ocean sediments exist on Earth today. 410 million billion tons. And we know the rate of continental erosion. We did that, you know, the amount the streams and rivers are bringing in the ocean, 27.5 billion tons per year. You do that division, you come up with 15 million years. Very similar to the length of time that the continents could endure, the present rate of erosion. 15 million years would be the apparent age of the ocean based on sediment in the ocean. Again, think about that. That's quite a bit shorter than the evolutionists would propose for the age of ocean basins. Life is supposed to have evolved in the ocean, the evolutionists say, over 3 billion years ago, and yet the oceans are still not full of sediment. You would expect hundreds of thousands of feet of sediment in the ocean if the continents have been eroding for 3 billion years. The small supply of sediment indicates that something's wrong with the notion of billions of years for the age of the ocean floor and the sediment thickness that's sitting on the ocean floor. Well, evolutionists have imagined complicated ways that remove sediment, that's subducted into the Earth's mantle or uplifted out of the ocean. But still, the problem remains that there's no major process that's removing ocean sediment as fast as going in. And so we have a different, we have a problem with the evolutionist way of thinking about the sediment thickness in the ocean floor. Well, let's ask the question, how long would it take for the oceans to get their present salt content? And this ocean's missing sodium, an evolutionary dilemma, is something that has become very apparent lately. You know that the rivers are adding not just sediments to the ocean, but salt to the ocean. The rivers are not as salty as the ocean, but salty water is going into the ocean, and of course the water evaporates from the ocean, becomes fresh, and it's delivered to the continent. Phosphate and calcium and potassium and other ions to the ocean. And we know the rate of addition of these ions fairly well to the ocean. Sodium and chlorine are the most abundant chemicals in the present ocean, and sodium content of rivers has been measured very well. It turns out that the present rate of addition of sodium to the ocean, divide the present amount of sodium in the ocean, we know how much sodium is in the ocean, divided by the rate that sodium is going into the ocean by continental weathering, and you come up with another number. 80 million years would be the apparent age of the ocean based on the salt content. And what do evolutionists believe about the ocean? Again, billions of years. The present level of sodium could be built up in just 80 million years of river weathering and erosion of the continents. Again, far short of what the evolutionists suppose about for the age of the oceans. Now, evolutionists have suggested that there are some major ways that salt is removed from the ocean. For example, deposited as rock salt deposits along the edge of the ocean, but it hasn't been proven to be a very significant quantity. And there isn't a major mass of sodium or sink of sodium in the salt deposits. In fact, the missing sodium is so much of a problem that evolutionists have been very reluctant to write about this subject. And the creationists are now bringing this to the point. For over 100 years, this has been suggested to be a good way to get the age of the Earth, and yet it seems to give an age far shorter than the billions of years that the evolutionists require. Now, don't let the number 80 million years bother you if you're a creationist, because how much salt would the ocean have had originally when God created it? Would it be fresh water when God created it? I think He created the ocean with salt already in it, and so it would have the appearance of age from the beginning. Well, I point the sodium problem out just to make this generalization. The ocean is not nearly salty enough to be 2 billion or 3 billion years old, the age required by Darwinism, assuming that life evolved in the sea. And so again, another problem with a billion-year age for things. Well, how about fossils and rocks? do the basic kinds of rocks and the fossil layers provide evidence of billions of years or millions of years in rock layers? Tomorrow night, and don't miss this, I'll be talking about Mount St. Helens, and I'll be talking about Yellowstone forests and other things, Grand Canyon, and you're going to see better reproductions of some of these slides when I project them with projectors on 2 screens. We'll have 2 screens set up here, and I'll be going back and forth between the screens, and we'll be looking at the effects of Mount St. Helens and Grand Canyon and Yellowstone and some of those major features. But you know, at Yellowstone National Park, we have very beautifully agastized trees, petrified wood, petrified trees that penetrate vertically through the rock layers in the earth. And here's an interesting cross-section that a geologist drew of the Specimen Ridge area in Yellowstone National Park. If you cut through the stratification or the layering there at Yellowstone, you might find 27 distinct layers with trees, petrified wood, logs, many of them in standing position, as this little illustration suggests. See these upright stumps that they've drawn on here? And many of those upright stumps, as the earlier drawing indicates, photograph indicates, are standing upright out of the earth. Well, this whole notion of upright logs buried in the earth and very beautifully petrified has been suggested by evolutionists to require immense periods of time. They've suggested for the petrified forest at Yellowstone, the 27 distinct layers, that those are over 50 million years old. Okay, and why do they suggest that? They suggest that these trees grew at the place where they're found. Those logs were growing there. Each level would represent a mature forest. Over thousands of years of development of a forest. On top of that, a soil developed. It was buried, a soil developed. Another mature forest. That was later buried. And then these are in situ forests. Repeated burial of trees in upright position is thought by evolutionists to prove great age for strata. It seemed like a very convincing argument, and you could argue for millions of years right there in the cliff. In fact, evolutionists have said that us creationists are ignorant and uninformed because we believe Genesis, which implies a young age for things, just thousands of years, and rapid formation of strata, like during the flood. Here is a cliff in Yellowstone, one cliff, where they say that we have multiple forests that grew there, each one a different level over millions of years. Tomorrow I'll be explaining this in more detail, but Mount St. Helens set up an amazing situation in the Spirit Lake, that lake directly north of the volcano in Washington State. In that lake, there are upright floating trees. Now, and I'll talk about this more tomorrow night. Trees float in upright position. They float and then they deposit on the bottom of the lake. Thousands of them are being replanted in upright position, and the root ends are being buried at different levels, having the appearance of being multiple forests which grew there over thousands or millions of years. Yet Mount St. Helens was just 8 years ago, the eruption, and this happened very rapidly. Evolutionists now are being challenged by creationists who are pointing to the bottom of Spirit Lake and saying, wait a minute, the Yellowstone situation looks more like the bottom of this lake, where these trees are floating and then being deposited in upright orientation. And here's a sketch that I'll be communicating more tomorrow night. The idea that logs float prone in the lake. An enormous wave on Spirit Lake on May 18, 1980 ripped loose a whole forest. 1 million trees were deposited. Logs were deposited and they float prone in Spirit Lake. And then we've noticed that they float in upright position. And then they can be deposited on the bottom of the lake. And then what can happen? Sedimentation is occurring rapidly in the bottom of the lake, and these trees are dropping out at different times. So what? They have their root ends buried at different levels, having the appearance of being forests that grew over thousands of years. Reasoning from my inexperience with the present, and thinking in terms of my customary way of thinking, I might assume great age, but now we know from scientific observations of rapid formation of rock. Also talk tomorrow about coal a little bit, and I'll talk about that again a little bit later in the next lecture tonight. But coal is one of my favorite rocks. I spent over 20 years of my life studying coal. And you know, the coal that we see is contains very beautifully mummified tissues of plants, especially bark and wood. And it has a layered appearance. You notice the layered appearance of coal? When I was doing my PhD dissertation at Pennsylvania State University, I was thinking about the layered appearance of coal and the root-penetrated or homogenized nature of modern swamp peats. And it caused me to question the conventional theory for the origin of coal. What is the conventional theory for the origin of coal? That coal built up from accumulation of plant material in a swamp. When you hear the word coal, the next word you're supposed to say is swamp, isn't it? Coal forms in swamps from peat that's accumulated. And, but you know, modern swamp peats have very different texture and nature than many of these great coal beds that we've studied. In 1978, I developed the theory, the floating map model for the origin of coal. The floating map model for the origin of coal, and defended it as a PhD thesis at Pennsylvania State University in 1979, July of 1979. I proposed that peat did not form in a swamp over thousands of years, every inch of coal building up, but that the peat was accumulated underneath a floating log mat, like you see here. Well, you know what happened at Spirit Lake? The volcanic eruption there at Mount St. Helens made a living modern example of a floating mat for me to study. And I'll talk about my scuba investigations of the bottom of the lake tomorrow night. So you want to see the actual slides, underwater photography of what the bottom of the lake is like. Thick layer of peat, over 3 feet thick, has accumulated not over thousands or millions of years, but in 8 years since the eruption. In fact, it accumulated quite rapidly, just a few months, we think, after the volcanic eruption. Well, do the types of rocks and fossils give evidence of long age? I just considered 2 here. I'll be dealing with some more later in the next lecture tonight. But let me just say that they do not provide proof of tremendous periods of time. Well, how about the property of stratification? You know, the layering effect in rocks? You know, we look at layering in the earth, and we see those layers or strata there. You know, my normal way of thinking about layering and strata is that each layer represents a long period of time, and alternations, the coarse and the fine layers, perhaps represent the alternation between summer and winter. Maybe in the summer we have less activity, and so we build up finer sediment. In the winter, we have more coarse sediment brought in by more water, and then that repeated action of that builds up thin layers into big, thick deposits that require thousands of years. And so the layering effect that we see as a property of strata might be assumed to be great periods of time, between summer and winter, between wet years and dry years, and the boundaries between those layers might be thought to represent long, long periods of time of inactivity, of nothing happening, or of erosion occurring. That's been my conventional way of thinking about strata. And evolutionists have said that you creationists have a problem because you believe that catastrophes make layers. Okay? Catastrophic process makes layers. And the evolutionists have said if catastrophe makes layers, it's going to make homogenized layers. You're not going to have minute, precise layering or stratification, even laminae formation. And guess what? What you're looking at is a deposit from Mount St. Helens that formed in less than 1 day by hurricane velocity surging flows. I thought it would be homogenized, all mixed up. It has very precise layering, very thin lamination that formed by a hurricane moving 100 miles an hour. Nobody was there actually to watch this. If you were there watching it, you'd be dead. It's a very active environment. But I'll talk more about how strata formed at Mount St. Helens. 25 feet of stratification, very thin layers formed in less than a day at Mount St. Helens, and challenge my way of thinking about stratification. You know anywhere else in the earth we have stratification? Grand Canyon, places like that. Sure, we want to think about other applications of this catastrophe idea. Well, evolutionists often say that the breaks between strata layers, these erosional features called unconformities, represent a time break of millions of years. In fact, more and more now, evolutionists are admitting that we can accumulate the strata rapidly. But the great periods of time they're putting in between the strata layers on surfaces of non-deposition or erosion. Some of these are called unconformities. For For example, in the Grand Canyon, I'll be talking about tomorrow night, we have the Coconino sandstone, very pure white sandstone, about 350 feet thick in the Grand Canyon, made from sand grains. That sits on the Hermit Shale, which is made from clay. Okay, and that's layered clay underneath it. And we have this very pronounced sharp contact. And that contact is of interest to evolutionists and creationists because elsewhere in central Arizona, we have over 600 feet of strata between the two formations. And evolutionists say, well, 600 feet of strata must represent several millions of years of deposition. So they say this contact right here in the Grand Canyon must be millions of years of missing time right along that boundary. But you can go look at it and marvel at the lack of evidence of millions of years. What might you expect if you had a erosion surface buried in the earth representing millions of years? The underlying material might be severely weathered. You know, soil development, pitting, canyon erosion, solution features. You might see residual lag boulders of the material overlying it. Instead, it's a very sharp knife edge contact, very level and flat. You kind of marvel at the absence of the evidence of millions of years. Even evolutionists themselves say, oh, they have to apologize for it because it seems like it's conformable. The two layers sit right on top of one another without obvious evidence of mismatch or erosion between the two, or is very severe weathering. Perhaps the most interesting of all in the Grand Canyon is the layer, one of the lowest layers, flat-lying layers in the Grand Canyon. The Tepiche sandstone sits on some diagonally tilted strata below, and we see sand that's built up on another formation underneath. And right here, you can go on a river trip. We go on the canyon every year. We go down there, put our hand on it. The erosion surface between 4,000 feet of flat-lying strata and then several thousand feet of diagonally tilted strata. You go put your hand on that. Evolutionists say 1 billion years of missing time exists on this surface right here. Well, half a billion years. They're talking something like that, a billion years to half a billion years of missing history. Again, you marvel at the lack of evidence of erosion, well, there is severe erosion on that surface, but canyon development or profile that might suggest extensive river, creek normal or erosive action. And you might expect soil profile development and very pronounced solution and chemical change due to the exposure of that surface. And yet we see it pretty much fresh lying there. And again, we ask the question, are millions of years or billions of years required for the erosion breaks between strata? Well, certainly one of the most interesting of all of the questions that we might ask about the age of the Earth has to do with canyons. Now, evolutionists say, surely you must believe in millions of years for the erosion of canyons. How long does it take to erode a canyon? Grand Canyon is the premier canyon on the Earth's surface, 217 miles long, 4 to 18 miles wide, over a mile deep in places. The total volume of the Grand Canyon is something like 1,000 cubic miles of material has been eroded away just to form the erosional form of the Grand Canyon. It's the most immense, one of the most immense canyons on the surface of the Earth. How long would it take the Colorado River eroding there to make that canyon? People have done the calculations. Actually, the Colorado River is moving about half a million tons of sediment per day through the canyon area, and could erode the canyon in just a matter of thousands of years at the present rate of erosion. Yet evolutionists imagine tremendous periods of time. Let me tell you about a statement that was made by Charles Darwin, an observation. He was studying the steep-sided canyon of the Santa Cruz River in southern Argentina. When Darwin was formulating his ideas about biological evolution, he had some theories about geological evolution that he was playing with. And he saw the valley of the Santa Cruz River in southern Argentina, a couple hundred feet deep, several hundred feet wide, steep-sided, and he saw a very small river flowing through that canyon. He thought to himself, my, that river has very small erosive power. How long would it have taken? An immense period of time for that to accumulate. Here's the statement. You can read this right out of Darwin's journal, A Voyage of the Beagle. The river, though it has so little power in transporting even inconsiderable fragments, yet in the lapse of ages might produce by its gradual erosion an effect of which it is difficult to judge the amount. In other words, Darwin made this enormous extrapolation, thinking about the present river, Santa Cruz River, and then he imagined geologic gradualism, gradual erosion, and then he extrapolated that into geologic time. And so he built his idea of geological evolution, and he went on to propose biological evolution. Well, I want to get down to the root question here that Darwin was playing with, had to do with canyon development. Are canyons formed slowly? Well, at Mount St. Helens, I'll be explaining tomorrow night, we have canyons that have appeared. Canyons that have appeared in very rapid sequence. This canyon is over 100 feet deep that formed after the summer of 1980 by some type of catastrophic agent and eroded through solid rock. Now, are you thinking contrary to the way Darwin is? Right there at Mount St. Helens, we have new canyon systems that have formed. There's very pronounced gully erosion that formed around lips of big steam explosion pits. Right here you see a pit that's over 100 feet deep. You see the gully erosion around the pit. That formed within 5 days after the May 18th eruption. Now, I had thought that gully erosion forms very slowly by water, hundreds of years perhaps, for rills and gullies to develop on a newly exposed surface. This didn't form by water erosion at all. It formed by slumping or by gravity collapsing the lip of this pit. And it reminds me of the Badlands of South Dakota or some of the desert terrain that we have here in the southwestern United States. A new way of thinking about erosion is in order. And then tomorrow night I'll explain my investigations of a new canyon system. I apologize the photograph here didn't come out too well. But we have a miniature Grand Canyon at Mount St. Helens, a 1/40th scale model of the Grand Canyon. Mud breached through here on March 19th, 1982. It unblocked the valley of the North Fork of the Tula River. And this breaching of this natural dam of landslide material produced a new drainage basin. A series of canyons, over 5 canyons come together at this breached terrain. We have over 140 feet of freestanding cliffs. And many of the features of the Grand Canyon, the flat upland surfaces, north and south rim of the Grand Canyon, we have that there. The mud breached through, but it did a snaky course. And northern Arizona, the Colorado River doesn't, and the canyon doesn't go straight through. It has a kind of a snaky path. We have these cup-shaped side canyons. We have these gully-like canyons, and many of the features at Mount St. Helens are repeated. Mount St. Helens repeated many of the things that we see in the Grand Canyon. So we nicknamed this the Little Grand Canyon of the Tula River. It causes you to wonder about the Grand Canyon. Well, you can go back and look at these canyons. This one canyon right here we see at Mount St. Helens, see over 100-foot tall cliff, several 100-foot wide valley, and what do we see? A small creek running down through that valley. Now, I might assume, not knowing about Mount St. Helens just 8 years ago, that this valley of that river was opened up slowly, one sand grain at a time, over an immense period of thousands or millions of years. That canyon was caused by that creek. Instead, the canyon causes the creek. It makes a drainage basin that accumulates water, and of course the creek has to go down through the canyon. It's a trapped river. Okay, it's not a river that formed the canyon. The river is trapped in the canyon. And we see the effect of, and so this is a fossil canyon, a relic canyon, a museum feature. You know, have you ever considered the Grand Canyon? There's a lot of speculations about the Grand Canyon. But I'll deal with the 3 theories for the erosion of the Grand Canyon more second lecture tomorrow. In fact, I'll tell you my testimony of how I was once an evolutionist. And when I saw the Grand Canyon 25 years ago, I believe that the Colorado River cut the Grand Canyon over a period of tens of millions of years. That was my original theory. All the textbooks told me that. The signs of the Grand Canyon pronounced that. But do you know that most geologists knowledgeable about the geology of northern Arizona and that are familiar with the Grand Canyon have junked the idea that the Colorado River cut the Grand Canyon? It sounds like heresy, doesn't it? But it's true. Geologists generally have dismissed the notion that the Colorado River cut the Grand Canyon. Despite the signs and everything the textbooks tell us, they've gone to other theories, 2 or 3, and have junked that idea. My original idea was that the Colorado River evolved the canyon over tens of millions of years. The plateau land was uplifted. The present course of the Colorado River continued to persist as the plateau uplifted, and we evolved the canyon over tens of millions of years. There should be an enormous delta west of the Grand Canyon. About 1 million cubic miles of sediment should be sitting there from 70 million years of erosion. You don't see anywhere near that amount of sediment. And then on the east side, you see something else quite different. And so geologists have decided that that theory is poor, generally. And they've gone to an idea that what I call the precocious gully theory, proposing the Grand Canyon was caused by gully erosion. A gully eroded eastward from Nevada through northern Arizona and captured the ancestral upper Colorado River, diverted it through northern Arizona through an enormous gully. The gully capture theory. That's probably the most popular theory for the origin of the Grand Canyon these days. I was attributing the Grand Canyon to the world's most amazing natural accident, a runaway gully erosion. The Grand Canyon Gully is incredible to think about, and I once was thinking that way. I'll tell you more about my gully theory. The third theory is the catastrophic drainage theory. It eroded rapidly when the plateau in northern Arizona was breached by drainage of a lake east of the Grand Canyon. There's evidence of impoundment of water east of the Grand Canyon, and the Grand Canyon could be a breached dam, very similar to Mount St. Helens, where you had mud breach a dam and form a miniature Grand Canyon there at the North Fork of the Toutle River. So we can go with alternate ways of thinking about canyon development and challenge even Darwin's speculation about millions of years for canyons. Well, by far, the most important evidence for billions of years, evolutionists say, are the radioactive isotope abundances. And radioactive isotope abundances are shown on this graph, or this diagram. Radioactive isotopes are, an isotope is a particular type of atom of an element that is radioactive, that disintegrates. And certain isotopes are radioactive, and so they decay or break apart into other elements. For example, uranium decays to lead. Certain isotopes of uranium decay to certain isotopes of lead, and they can be used to measure, they suggest, ages of things. For example, if you start with 16 atoms of uranium and come back one time period later called a half-life, 8 of those uranium atoms will have decayed to lead, and only 8 of the uraniums endure. Then you come back after a second half-life, and half of those uraniums decay to lead, and so we have 4 atoms of uranium left and 12 atoms of lead. And you come back after a third half-life, we only have 2 atoms of uranium left, and we have 14 atoms of lead. This whole thing is a radioactive decay process. Notice it's not a constant decay rate or a linear decay rate like a candle burning, but it's very similar to candle burning. Instead, it's like an hourglass kind of thing. And uranium going to lead, not at a constant rate, but at this continually declining rate. So that's what radioactive isotope decay is supposed to be like. Well, you can draw this on a diagram as I've done here. You can see what we call the exponential decay of uranium to lead, or rubidium to strontium, or potassium to argon. And those candle burns at a constant rate. These minerals, or these minerals in the earth that contain radioactive elements, these particular isotopes, they decay not at a constant rate, but at an exponentially declining kind of rate. That can be described by a mathematical equation. Do not let the math confuse you or alarm you. Maybe some of you can do this algebraic problem, but this curve is described by an exponential equation. I'll just briefly describe this equation so you can understand the assumptions that go into radioactive isotope dating. This equation says that the uranium-238, that's the isotope number 238, uranium with atomic number in the nucleus of 238 particles, that uranium-238 now that occurs is equal to the uranium-238 that was originally there in the mineral or rock times E, and E is the natural base of logarithms, 2.71828. That's a certain mathematical quantity that gets into these exponential curves. E raised to the power minus lambda T. And lambda is the probability of uranium decay, uranium-238 decay. It's related to the half-life by this algebraic relationship. Anyway, lambda is the probability of it decaying, and T is the time or age. And you can solve for this equation. You can solve this equation for T if you know the amount of uranium in the mineral now. And we can measure that very accurately in a chemical laboratory. And we know we can measure the rate of the probability of decay, or the rate of decay of uranium now. So we can come up with a probability number that goes in for lambda. And we know what uranium-238 is now. In order to get T, the number of age, we also have to know uranium-238 that was originally there. Okay? Do you see the colossal nature of the assumptions involved in radioactive dating? You have to know how much smoke was in the room originally, or how high the candle was. And the evolutionists say that they can put a number in there for that amount or that quantity. Again, see, it's the smoke in the room or the candle. If you look at the uranium now and uranium that you think was there originally, it's the height of the candle method. If you look at the lead, if you write a lead equation for this decay, then it's the smoke in the room problem. Most of the radioactive dating is done by the smoke in the room calculation, but I'll just show you that there's there's an example of how they do the time calculation. What you need to see is the equation to know that they use certain numbers they put in there. You need to understand the colossal nature of those assumptions they put on those numbers. There are two types of dates. There are what are called model dates, isotope model dates, and isotope isochron dates. A model date is a single isotopic analysis. For example, like we see here, a single isotopic analysis for uranium could be used to make a date. If we know the uranium originally, and we know now, and if we have the probability of decay, we can estimate time, age. That's a model date. A single isotopic analysis of a rock or mineral is used to solve the dating equation for time. That's what's called a model date. Those have been used in the past, but more and more now, geologists are going to method number 2. It's called the isochron date. Isochron dates. Multiple isotopic analyses are made of several rocks or minerals from the same formation. It makes a graph or plot of the single rock formation that can be analyzed for age. The slope of the line through the data points is directly proportional to the age of the formation. And that's called an isochron. Let me show you an example of an isochron. You might plot strontium isotopes against rubidium. Rubidium-87 against strontium-87. Rubidium decays to strontium, and this diagram shows a plot that was made. Okay, and the slope of this line, it increases with age, supposedly. If it was flat, no slope to it, it would be 0 age, and the more increase in slope, the greater the age. And so now more and more geologists are using the slope of that line. It also involves assumptions. It's very similar. We have to know some initial condition assumptions. But anyway, the isochron method is used more and more. Instead of relying on one analysis of one rock, we have a whole series of analyses, and geologists feel very confident often with isochron dates. Isochron dates. I'll be getting back to some of these isochron methods in a minute, since they're the ones that geologists need to work with more and more. Well, anyway, this slope of the line technique also is estimate of age, they think. It helps confirm some of the assumptions of radioactive technique. Let me just call your attention to the fact that this is also very similar to this problem of the candle. You know, when was the candle lit? We either use method number 1, to look at the candle method, or method number 2, the smoke in the room method. And uranium decays to lead, thorium-232 decays to lead-208, uranium isotope number 235 decays to lead isotope number 207, uranium-238 decays to lead-206, lead-204 is the naturally occurring lead that doesn't come from radioactive decay. So you can measure all the lead isotopes and uranium and thorium isotopes in rock and come up with age. The half-lives of the radioactive decay are on the order of billions of years, and so evolutionists say that uranium-lead techniques should give ages of billions of years. Another technique is potassium-argon. It's often used by geologists. Potassium-40 decays to calcium-40 and argon-40. About 11% of it decays to argon-40. Its half-life's about 1.3 billion years for this decay, and it is very common. Potassium is common in the Earth, and so argon is a gas that can escape out of the rocks, but they think that that remains sealed, and so we can use the smoke in the room calculation method to estimate age that way. And rubidium-strontium, rubidium-87 decays to strontium-87. Half-life is somewhere around 40 billion years. That's a probability number. It has nothing to do with the age of the Earth. It's just related to the probability of rubidium decay. We'll take a look at the assumptions of radioactive dating techniques, and I'll call your attention to these. Constant decay rate. Constant decay rate. The isotopes decay at a constant rate. Are we willing to acknowledge that? For the sake of the critique of radioactive isotope dating techniques, I think we can grant that. Number two is the one that I think is the major problem with radioactive dating. The initial quantity of parent or daughter product can be known. In other words, we can know how much smoke was in the room originally, or how high the candle was, that kind of thing. That's the major problem. And then we have to assume that there was no loss or gain of parent or daughter product as has occurred over the history of the mineral or rock we're trying to date. In other words, a closed system idea. Let's take a look at that number two assumption and talk about some of the problems. Here's a list of problems that I think involve radioactive dating techniques. Discarded dates is the first problem. It turns out that being a geologist, I've been exposed to this with my colleagues quite a bit. Most of the radioactive isotope techniques that have been used and the dates that have been, isotopic analyses have been performed, have been generally discarded or thrown out for some reason. They just do not agree with what the geologist's opinion about the ages of things are. In other words, radioactive dates are critically evaluated by geologists, and if they agree with the geologist's preconceived ideas, they're accepted. But often they aren't, and they're discarded. And so they go into the trash can, okay? And you could critique radioactive techniques of dating that way and say that they've just estimated billions of years by accepting just certain dates. Anyway, discarded dates is a problem for the, you would think, for the reliability of the whole discussion of radioactive isotope abundances. But still, many dates now are not discarded, and so we have a large body of isotopic data about formations. Number two is discrepant dates. Discrepant dates. Sometimes a date is published in the geologic literature, but it's discrepant with the paleontology or the strata layer that the geologists have already assigned to a certain age or date. And discrepant dates exist. And they're often not they're apologized for without much explanation. So that occasionally they get in the literature, they're discrepant dates. Number three is the major problem I see with radioactive dating techniques. It's discordant dates. Assumption number three, or problem number three, is discordant dates. Often you will date the same rock by two different methods, and you get different ages, radically different ages. In fact, I was thinking to myself, do I know of any potassium-argon date that agrees with a rubidium-strontium date for the same rock? And after I thought about it for a while, I can't think of any that have agreed. Often the rubidium-strontium date is very much older than the potassium-argon date. Then we have to explain how some argon leaked out of the rock. or some smoke got out of the room kind of thing to make the potassium-argon date look too young. Discordant dates are very common. And then fictitious isochrons or discordant isochrons is a problem. I'll just explain that in a minute. Often two isochron plots do not agree for the same rock. And then there's these uncertainties about cosmic abundance ratios. The cosmic abundance ratio is how much smoke was in the room originally. You know, those lead techniques and uranium techniques have a built-in fudge factor. It's called the cosmic abundance ratio of uranium and lead. And they put that fudge factor in there, and that helps get great ages. And so there's uncertainty about that cosmic abundance ratio, and that's changing. And nevertheless, it's true that geologists assume that meteorites form from the same cloud of gas that the Earth condensed from. Therefore, the meteorites have the same isotope ratio, and so we calibrate the uranium-lead techniques and other techniques on the basis of the isotope ratios of meteorites. And we bought into a cosmology that the Earth and the meteorites form from the same solar nebula. And that doesn't fit too well with creationist ideas. So again, there's major assumptions involved there. Let me tell you about a practical application. I've been working on the Grand Canyon dates, and I've been examining all the radioactive isotope analyses of Grand Canyon rocks that I can find. There are two lava flows in the Grand Canyon. They should be easily dated. There's one deeply buried lava flow that exists under 4,000 feet of strata, actually under 10,000 feet of strata in one place. And this lava flow is called a pre-Cambrian lava flow, suggested to be over 1 billion years old. The age for this came out with the rubidium-strontium isochron technique, 1,090 million years, 1.09 billion years. The potassium-argon isochron method, however, gave an age of 795 million years, significantly less. The two techniques disagree. They said that there was argon leakage by some type of heating of the lava flow after it formed. Argon leaked out, making it appear by the potassium-argon technique too young. Therefore, the rubidium-strontium age is the accepted age for that formation. Well, I've got some recent isotopic data from lava flows that flowed over the rim of the canyon. On the north rim of Grand Canyon, lava flows flowed over the rim. And I have rubidium-strontium isotope data. And so I plotted my own isochron plot for those lava flows. Got 1,500 million years for a lava flow that flowed over the rim of the Grand Canyon and blocked the river. And it's a nice isochron. I'll show it to you in a minute. 1,500 million years, 1.5 billion years, even older than a deeply buried layer. And yet the potassium-argon age was something like 1 million years, less than that. And it looks as fresh as any lava flow from Vesuvius. And so it's no Indian record of it flowing out, but it seems to be a very recent lava flow. And yet it gives 1.5 billion years as an age by the rubidium-strontium technique. So there's something wrong with the rubidium-strontium technique, a fictitious isochron problem. This shows the deeply buried lava flow in the Grand Canyon. It's in the eastern Grand Canyon, and we go see that every year as we float through the canyon on our Grand Canyon trip. But that deeply buried lava flow gave discordant dates. Gave 1,090 million years by the rubidium-strontium technique, 795 million years by the potassium-argon technique. I can show you this. Here it is. Here's the isochron plot. The strontium-87-86 ratio plotted against the rubidium-87 strontium-86 ratio gives a linear arrangement like that. That's been published in the geologic literature, and geologists now accept that as the age for that formation. But I have published this isochron plot on the basis of new isotopic analyses of that recent lava flow that flowed over the rim of the canyon. It gives an age, an even higher slope to the line, greater age, 1,500 million years, 1.5 billion years. That, of course, is preposterous. The Grand Canyon could not have existed as an erosional form for 1.5 billion years. Therefore, there's something wrong with the rubidium-strontium isochron method. Here's the potassium-argon isochron that was done for the Cardenas lavas, that deeply buried lava flow. It gives a sloping line of 795 million years, plus or minus maybe a few tens of millions of years. Certainly the uncertainties are quite different than and make it quite different than this rubidium strontium technique. 795 million years, this has got to be explained, and geologists have a hard time explaining. Look at the nice correspondence of those points to that line. Correlation coefficient of 0.999. You know, linear plots just don't happen like that by accident. You have to explain that, and you've got to explain that by some very significant process. Not only have rubidium strontium and potassium argon plots been done, there's a whole suite of evidence published on volcanics from the Colorado Plateau area. Included on this diagram are several lava flows in the Grand Canyon area. And you notice that you plot these on a line. They plot quite nicely. This is the whole Colorado Plateau, areas of 4 states. And we're getting a nice linear plot like this. 2.2 billion years is the slope suggested by these points. And do you know, though all of those are what are called Cenozoic volcanics. Thought to, all of them formed in the last 30 million years. Most of them in the last 1 or 2 million years in the evolutionary way of thinking. In other words, all of the volcanics of Colorado Plateau give deceptive lead-lead isotope ages, lead-lead isochron age. And not only that, think about this, you use a different lead isotope and you get 2.6 billion years for the same data. 2.6 billion years. And so this discordancy problem is calling into question everything that we know about radioactive dating. It seems to me that these ages are inherited. Okay, the lead isotope ratios that indicate this age are not caused by radioactive decay in the rock, but are caused by inheritance of the isotopic ratios from the lavas as they come out on the surface of the Earth. They have the appearance of being great age as they form. If that's the case, then the deeply buried lava flows could be the same way. It calls into question all of the major radioactive dating techniques made for Grand Canyon rocks. And are we sure that those rock layers are billions of years old? Don't have any real proof. These are exceptions to the notion of great age of things. We've gone through some of the basic questions relating to, is the Earth billions of years old? We talked about the assumptions needed to estimate the age of the Earth. There are some very significant assumptions. We need to know those. We talked about how long it would take to erode the continents down to sea level. We asked that question. We asked how long would it take for the ocean sediment to build up. In both cases, the continents could be eroded to sea level in about 14 million years, and the present thickness of ocean sediment could be built up in about 15 million years. Very much different than the evolutionists have required for the age of the ocean. Number 4, does the ocean salt content suggest a billion-year age? No, it suggests a significantly younger age. And evolutionists have a major problem with explaining where all the sodium has gone. The ocean should be loaded with sodium. It can hold 20 times as much sodium as it does now, and it should be totally saturated with sodium given 3 billion years, the evolutionary age for the ocean. And yet the ocean salt content suggests an age of just millions of years, assuming that we had no salt content in the ocean originally. And do the rocks and fossils take long ages for deposition? We looked at fossil deposits. We find petrified wood, standing trees, how those have been assumed to require great age. Looked at coal beds, and I'll be talking more about that tomorrow night. Those don't require great age. They can be formed rapidly. We're expanding our way of thinking with catastrophe theories for the origin of rock and fossil deposits. Does the property of stratification in rock require long ages to form? The stratolayering we observed at Mount St. Helens forms rapidly, and catastrophes also can produce layering. And does the erosion breaks between, do the erosion breaks between strata, rock strata require long ages? And we looked at some of those breaks, those erosional breaks or unconformities, and saw evidence, a lack of evidence for millions of years. And so we kind of wonder, is there geologic ages missing on those, between those formations? Sometimes I find myself questioning that idea. And does the erosion of canyons require long time periods? New ways of thinking about canyon development call into question the evolutionary notions based on our inexperience with the present, and cause us to wonder about how whole canyons can develop. There's been some tremendous problems with the erosion of the Grand Canyon by the Colorado River and other canyons forming that way, and so we need to think in terms of catastrophic agents for erosion and short periods of time for canyon development. And due to the abundances of radioactive isotopes and rocks require millions or billions of years, we've looked at some of the isotope evidence. The radioactive isotopes do not provide a consistent, clear, concordant picture about the ages of strata. And the more we dig into this and the more the analyses come in, the more uncertain it becomes that these age techniques by radioactivity are really correct. So we have no solid evidence in the radioactive isotope abundances that these rock strata layers are indeed billions of years old. You know, there's a word that might describe where we're leading with this discussion. You ever heard of the word and the definition of the word myth? What is a myth? It's an illusion of an age or culture whereby life and its origins are interpreted. That's the dictionary definition of the word myth. An illusion of an age or culture whereby life and its origins are interpreted. Could it be that we have a nature myth, a scientific myth, a once upon a time myth? Instead of once upon a time, billions of years ago, we tell that myth. The purpose of a myth is to provide an age or a culture, a criterion for judging and assessing reality. That's the purpose of a myth. And it's to dispel other myths. And could it be that this is a nature myth that we have, the Earth as being billions of years old? I believe that there are some evidences of young age for things. We need to be looking at evidences for thousands of years for rock strata layers. Some things at Mount St. Helens might cause us to think about thousands of years for Earth age. Other geologic processes might suggest thousands of years for the age of the things. We need to be thinking in that frame. I believe that the evidence is inconclusive for an Earth billions of years old. In fact, the more that I study geology, the more I am inclined to think in terms of an Earth just thousands of years old. Okay, you might say that I've gone through a tortuous evolutionary process, okay, from believing in an old Earth, billions of years old, and started questioning my own assumption base and the mythology that was bogging down my mind. Then I started looking at the scientific data, and it's being inconsistent with the Earth billions of years old. Now I'm asking myself the question, could it be that the Earth is just thousands of years old, like Scripture says? Okay, I'm not convinced that the age for billions of years is really substantial, and the door is open for me to believe in the beginning God, and not so long ago. Thank you so much.